All right, we've got our training data set up, we've got our validation data set up. Now we just need to build the model. So remember there are 2 steps here, well 3 steps in total, but the first 2 are grow the decision tree and then prune it back. It's possible that our decision tree will be so complicated that we can prune off a few branches, which would make the model simpler and easier to use, without losing any classification accuracy, right? So here's where we're creating the model, and here's where we're pruning the model. So we'll go through those steps. Here I'm creating an object called the tree, which is just my decision tree classifier. It is the result of the rpart function where I am trying to predict the groups. Remember, this is just a list of dry, rainy, or none. In order to predict groups, the data that I'm using are the training data that I created before, and I'm setting my method equal to class. In other words, I don't want the numeric answer back. I want it to say, I want my answer to be dry if the model thinks that gorillas will be in that pixel during the dry season. Okay, so here in this line I create that model, and the next 2 lines plot the tree. I am not sure why R does this. It has plotted the tree but not put any of the labels on it, so you have to go down to text the tree in order to add those on, and we can see that it's a little bit complicated. Our first division, and because of the height of this, also the one that seems to be the most useful, is to say that anything below a vegetation value of 3.5, those would be classes 1, 2, and 3, and anything above that, classes 4, 5, and 6, would come down this way, right? So if you are 1, 2, or 3 in vegetation class and your elevation is greater than 1,800 feet, then there are probably no gorillas there. If you are less than 1,800 feet, or greater than or equal to 1,800 feet, and also greater than or equal to 1,945, then you're probably dry. There are gorillas there in the dry season. If not, then we have a threshold down here for aspect. So we've included roughness, aspect. The topographic index is coming in here to discern between none and rainy. So we have a very complicated model here, and I kind of suspect it's maybe too complicated. We can get rid of some of those lower branches and it won't hurt us very much. So this command, print CP, prints our critical values here and lets us know the smaller these values get, the more likely it is that we can lose them without affecting our accuracy. So the easiest way to look at that is probably to plot CP. And anything below this dashed line, which is at 0.5, is probably something we can lose without feeling too badly about it. So we can lose these and this and this. So this is the size of our tree. Here we're getting to 13 branches. And we're saying we can reduce that down to 10 branches and our difference will only be 0.01. So we can lose that. We haven't lost any accuracy. We can go down to 8 branches and we're only at 0.05, which is only 0.03 greater than initially. So I think we can lose that. I think I'm going to try to go down to a decision tree of about 7. So I'm just eyeballing it here. There's no real trick to this. We sometimes call this a bent stick method, where we look to see where the stick has bent. I like to be just a little bit more liberal than that, so instead of cutting it off right here, I'm going to include this one, which means that my critical value is somewhere between 0.017 and 0.015. So over here in my prune command, I'm saying I want to prune that tree, only include those values whose critical points are less than 0.016. So I just picked a number right between here so that it should include these 3 models, and I should stop with one that has 7, right? So I'll run this model, or I'll run this command, and I will plot that, and we can see that I have now a much simpler model. And I can throw the labels on there as well. So now it's just saying anything that has a vegetation below 3.5, chances are there's nothing there. If you're above that and you have an elevation that is less than 1671, then it's probably rainy. Otherwise, we come down to elevation where it breaks this again. If you have a roughness less than 21.5, then there's probably nothing there. If it's greater than that, then there are probably gorillas there during the rainy season. So you can see we've created a simpler model and one that we will use now to predict for the rest of our data, or to predict gorilla sightings throughout the rest of the park.